Alright, so in 6.3 we talked about this thing called parametric equations. So in 6.4 and 5 we're talking about polar equations. So switch over. These are some examples of graphs with polar equations. And notice they look very, very different than some of the equations we've seen up to now. But these are examples of what a polar equation looks like. And if you see at the very bottom of the screen, you'll even see some equations, polar equations. And you'll notice that instead of using x and y or even t like in parametric, we're using completely different symbols. We're using r and theta. Okay? So r and theta are the variables we'll be using with polar equations. To understand parametric equations, or the r and theta, r stands for the radius and theta is our angle. So when I graph a polar equation, we're graphing it based on a radius at a given angle. So for whatever the angle is, it tells me what the radius should be at that point. So that's why we get very circular looking graphs when we're graphing polar equations. Example is this one on the board. Notice I have 4 different points plotted along here, A, B, C, and D. Well, point A is located right here. Now first thing we'll look and see, what is the radius? Well, the radius is marked along here. It says this is 2, 4, 6, and 8. And I see that A is on this solid line halfway between 6 and 8. So A must have a radius of 7. I also see that A is on this line right here, which has a angle of 60 degrees. So the polar coordinate for point A is 7, 60 degrees. Look at the other ones. We'll look at B. B is right here on the outside. So if I bring it along, I see that it's outside of 8, so 1 more than 8 would be 9, so B has a radius of 9. And the angle associated with B is 300 degrees. Next I'll look at C. C is located right here, and if I follow this line around, I see that it is at 4, so C has a radius of 4. And then if I follow this line out, I see C has an angle of 150, so 150. And then lastly, D. D is right here, and if I follow this curve around, I see it's at 6. And D has an angle of 210 degrees. Okay. So that's how I can write the point if it's given. Well, on your paper, you're given a point and asked to plot it. So I first see the 4. My radius of the point I'm given is 4. So that means I'm going to be on this, I see 4 is right here, so I'm going to be on this outer circle, this outer radius. And I need to find 195 degrees. So if I go around, I see 60, keep looking, 180, 210, okay? Well, I don't see 195, but I see 180, and I see 210, and no 195 is between those. So this line right here is my 195 line. So this is the line I'm on, and because I'm at a radius of 4, and 4 is the outermost, my point is right there. That would be my coordinate point. Go ahead and pause the video right here and try number 2, and then after you have a chance to attempt number 2, I'll show the answer. So I'm going to pause the video now. Alright, So for number 2, it has a radius of 2 and an angle of 270. Well, 270 is actually on my circle, so your point should have been plotted right there. Next, we'll look at one that instead of being in degrees is in radians. Well, my radius is 1, so I'm going to be on my inner circle. And my angle is 23 pi over 12. Well, that is not on my circle. But if I want to figure out where 23 pi over 12 is, let's think about, well, 23 is in between 22 and 24. So 23 over 12 is going to be in between 22 pi over 12 and 24 pi over 12. Well, 22 pi over 12, I can divide both of those by 2 and get 11 pi over 6, which I see is right here. I could divide both of these just by 12 and get 2 pi. Well, I know that 2 pi is the same thing as 0. So I found those two angles, and since 23 over 12 has to be between those two, then it has to be this line right here. And specifically, since my radius is 1, it's going to be right there. Alright, so go ahead and pause the video there and see if you can do number 4. Alright, so for number 4, I see the radius is 4, so we're going to be on our outermost radius, and 7 pi over 4. Well, again, I'm looking at my circle, and I don't see 7 pi over 4, so let's think. 7 pi, it's going to be in between 8 pi and 6 pi. Well, 6 pi over 4, that's the same thing as 3 pi over 2. Well, 3 pi over 2 is right there. 8 pi over 4, well, again, that's the same thing as 2 pi, which is right here. So I have a wide range, but let's think, what is exactly halfway in between 3 pi over 2 and 2 pi? Well, if I do exactly halfway, or at 45 degrees, I'm at this line right here. And since my radius is 4, I'll end up right there.